Hello, in this class I will discuss law of parallelogram. So, before doing some mathematics, let's first discuss why do you require such type of the laws in classical mechanics. So, if I consider a body which is acted upon by many forces in different directions, okay, so F1, F2, F3, F4 and F5 forces acting upon a body of mass m. So if you want to write the equation of motion for this object, for this body of mass m, so equation of the motion so this is the equation of the motion of the body. So if you want to describe the motion of this body, then you have to solve, or we need to solve this equation of the motion for individual forces. Okay, so then we can understand the motion of this object or this body. So motion of body, to understand the motion of this body, we need to solve equation of motion for all forces. So in this way the problem will be more complex. So therefore we need to simplify this problem. Okay, so simplification to such problem is needed. Then what is the way, or what is solution to make such problems as simple as possible? So if now let's say we have these different forces acting on object in different direction. Okay, so now this is the many forces. So if we can convert all these forces into a single force, okay, so this is the single force, then the problem was the complex here. Okay, now here problem will be simple. It means the motion of the body will be simplified if we can convert all these acting forces on the body into a single force. So for this, okay, so for this we need to use some laws. Okay, so it is not easy to simplify this problem, or we cannot convert directly any complex or any group of the forces into a single force. So we need to follow some rules, or we need to follow some laws. So there are many laws. Okay, so there are many laws. For converting, or we can say for the transforming many forces into a single force, or in another we can say we can get forces to a resultant force. Okay, so the different type of kind of the forces, and when we convert these forces into a single force, then we call this force as a resultant force of these forces. So now we use the concept of the law of the parallelogram, or concept of the parallelogram. Use the concept of parallelogram in finding a resultant force. Okay, so let's consider an object in this plane, and two forces, one is P, one is Q, acting on this object. And if I draw the line of action of this force, line of action of this force, the line of action of this, okay, and this is angle between the line of action of these forces. So now if I convert this problem, so this is the force P, and this point, intersection point is O, is here. Okay, so this point is O, and this point is, this force is Q, and if I make a parallelogram, okay, so and then theta. So if we can represent the forces acting on the body in this way, it means this force P is one side of this parallelogram, force Q is another side of parallelogram, then the resultant force will be the diagonal of this parallelogram. Okay, so I can write in the word So if forces are represented by two adjacent sides of a parallelogram, then the resultant is represented by diagonal of a parallelogram which passes through the point of intersection of the two sides. Okay, so if the forces P and Q, two forces, are represented by two adjacent sides of this parallelogram, then the resultants will be represented by, or we can say the diagonal will be the resultant of these both forces, which is passes through the intersection of these two forces or of these two sides. Okay, so this is the law of the parallelogram. If the forces are represented by the two adjacent sides of the parallelogram, then the resultant force is represented by the diagonal, then their resultant is represented by the diagonal of parallelogram which passes through the point of intersection of these two sides. Okay, so this is the law of the parallelogram. So now we can, if there are two forces acting on the body, so we can get one single force by using the law of the parallelogram. Okay, so we can make problem simple if we use only a single force instead of using two different forces for a single object. So now what is the magnitude and angle of R? Okay, so now what is the magnitude of the resultant force and angle of R with P or Q? So to get the resultant value of to get the magnitude of the resultant force R, we can use the law of the triangles. Okay, so what is value of the R? Now this is the question, so we can use the law of triangles. So again, P. Okay, so magnitude, length of this x side is q, length of this side is p, and this is the parallelogram. So now this point is, let's say, B, and if I draw a perpendicular on this axis, then this is 90-degree angle here, and this point is, let's say, if I assume this point is D, okay, so this point is D here, and up to here this point is A, and this is the theta. So now the resultant force, this is R, so magnitude is R, so R equal to, we can write, is R cap. Okay, so we can write the forces, the total P is magnitude, and Q, magnitude is Q, and direction is Q cap, and R, resultant is R, and then R cap is the direction. So now we can use two triangles here. So this angle is also theta, this angle is theta, this angle is theta. The length of this side is also Q, length of this side is also P. So now we use the law of triangle. So triangle ABD, okay, this one. This is A, this is D, and this is B, okay, and this is angle theta. So BD divided by this length is Q equal to sine theta. This implies BD equal to Q sine theta. Similarly, AD divided by Q is cos theta. It means AD is equal to Q cos theta. Now we can use another triangle. So this, the length of side is R, and this point is O here. This is the A, and this is the D, and this is the B. Okay, so now use an angle, this is alpha here. Okay, so this is alpha here. Now triangle OBD. So we use the concept of right triangle. It means the Pythagoras theorem. So OB square equal to OD square plus BD square. Okay, and this length, this is the P, and this is Q cos theta, and this length we already estimated, this is the Q sine theta. Okay, so now we can use the length, the estimated length OB is means R square equal to OD means P plus Q cos theta square plus Q sine theta square. So a plus b whole square, p square q square cos square theta plus 2pq cos theta plus q square sin square theta. P square plus q square cos square theta plus sin square theta plus 2pq cos theta. So p square plus q square plus 2pq cos theta, or we can write r is p square plus q square plus 2pq cos theta. Okay, so this is the magnitude of r. Magnitude of r. So if you know the magnitude of one force P and second force Q, and then angle between the both forces, then we can estimate the resultant force acting on the body. Now, what is angle of R? Angle of R with P or Q. So we can again use a triangle. Okay, so O D. Okay, this is R, this is B, and this angle between R and P. Okay, this is A here. So this is the P, this is the R cap, this is the P cap. So now use again triangle, law of the triangle, O B D. Tan alpha equal to OD, sorry, BD divided by OD. Okay, BD is Q sin theta, and this length is P plus Q cos theta. Okay, so Q sin theta divided by P plus Q cos theta, that is equal to tan alpha. So the alpha equal to tan inverse Q sin theta divided by P plus Q cos theta. So if you know the P, magnitude of the one force, magnitude of second force, and angle between these forces, then we can estimate the angle alpha, which is between P and R. If so, this was simple angle between the P, and this is the force Q, and this is force R, and this was angle alpha. Similarly, we can also estimate the angle of R with Q. Okay, so let this is the resultant force, and this is the angle alpha prime. So the alpha prime, tan alpha prime will be P sin theta divided by Q plus P cos theta, or we can write alpha prime equal to tan inverse P sin theta plus Q plus P cos theta. Okay, so we can estimate, or we can find the value of alpha prime. So angle between resultant force and Q, and alpha angle between R and P. Now we can consider some cases. So first case, if theta equal to 0 degree, means P is parallel to Q. If P and Q both are in same direction, then what will be the resultant force? So we can use the law of the parallelogram, or result of the parallelogram. So we know that R equal to under root P square plus Q square plus 2PQ cos theta. Okay, so theta equal to 0, it means cos 0 equal to 1. Then the R will be P square plus Q square plus 2PQ, or we can write P plus Q whole square equal to, then R equal P plus Q. Okay, so this is the magnitude. So we can, the resultant magnitude will be magnitude of sum of the magnitude of the both forces. Or in vector form, we can also write vector form P plus Q. Okay, this is in the vector form. So the resultant force will be the sum of the both forces, sum of P and Q gives you resultant value. Okay, so now we consider second case. If theta equal to 90 degree, it means P is perpendicular to Q. In this case, R will be P square plus Q square plus 0, because cos 90 is 0. So the R will be P square plus Q square under root. Okay, so this is the, we can estimate the resultant force, and the resultant force is independent, right, is independent of angle. So the resultant force is independent of angle. Now we can consider third case. If theta equal to 180 degree, it means P is anti-parallel. In this case, cos theta equal to cos 180 equal to minus 1. So the resultant force will be p square q square minus 2pq, or we can write p minus q whole square. So the resultant will be p minus q. So this is the magnitude, or we can also write in vector form. So resultant force will be in this form. Okay, so this is the summation of two opposite forces. So difference of magnitude of these forces will give you the result, will give you the magnitude of resultant force. Now we consider the last case. Let's say if magnitude of the P is equal to magnitude of the Q, or we can say the P is equal to Q, then the resultant force P square plus P square plus 2P square cos theta, or we can write 2P square plus 2P square cos theta, or 2P square 1 plus cos theta. Okay, or we can write here so 2P square 2 cos square theta by 2. So 1 plus cos theta equal to 2 cos square theta. So this is the 4P square cos square theta by 2, or we will get 2P cos theta by 2. Okay, so this is the value of resultant force. So if we know the value of one of these forces, an angle between these two forces, then we can estimate the resultant force of both forces. Okay, so this was the application of the law of the parallelogram to understand the resultant force of two forces which are acting at different angles. So I hope you learn about the law of the forces and other applications to get the value of resultant force. Thank you.